Hello. Yeah.
Ma'am, my screen is visible.
1 minute. 1 minute.
Yes.
Yeah, you can. It's visible, but your PPT is not visible. Yeah.
Now my PPT is visible.
Yeah, it's visible. Make it full screen. Make it full
Okay,
screen and go
okay,
for it.
okay, ma'am. Thank you. Okay. Hello, everyone. My name is Sima Bakhtar. I am working as a hydrogeologist in Project Engineering Controls Private Limited in Kolkata. I am presenting pixel-based trends mapping in the Guinea region of the West Africa, integrating remote sensing data and mod flow modeling for sustainable resource management and monitoring. This and the some parts of this research is contributed by the Dr. Abdul Ram Purwala. He is the director in Pioneers Numeric Limited in the United Kingdom. This is the presentation highlight of my overall research, and the first is the introduction of the study area, overview of the ground resources in the study area, that is the Guinea region of the West Africa, and the study area and its geology, overall research workflow diagram, after the statistical analysis for the meteorological variable through box plots, and then spatio-temporal modeling for of meteorological variable like groundwater storage, rainfall, temperature, relative humidity, and normalized vegetation index. And then we will see the workflow procedure for the mod flow modeling, and we will see the result of the mod flow simulation for and volumetric result of this, and then we will come to the conclusion parts, and we will then we will see the strategies for the sustainable groundwater use and technology and innovation in groundwater monitoring, and finally we will the efforts and initiatives for sustainability. Now we will see the first introduction part of this study area. Basically, the study area is the Guinea region of the South Africa, and in this the groundwater discover the current state of the groundwater resource in Guinea, South Africa, and explore the challenges, impacts, and initiatives in protecting and managing its vital natural resources. If you see this map, uh, by this is the all state of the West Africa, or country of the these are the countries of the West Africa, and see the or day by day the recharge condition of in these areas is in a declining position. uh, and what is the overview groundwater resources in this region? The first is the abundance. The Guinea, South Africa is blessed with a vast groundwater resource, making it a crucial water supply for the communities and ecosystem. And it depends on the groundwater supports agriculture, industries, and domestic water needs, playing a critical role in the region development and sustainability. And the third one is the complexity. The geology and hydrology of the region contribute to diverse aquifer system, each with unique characteristics and vulnerabilities. And the current challenges and threats. What is the current challenges and threats in this region? The first is the over exploitation. Day by day, unregulated pumping and obstruction of the groundwater pose a risk of the depleting aquifers, and this will be see this result we will see through, and we will see in the next slide, leading to the water scarcity and subsidence. Second one is the major challenges is the and third is the contamination. It's a major problem in this region. Pollutants from the mining activities, because in Guinea, in West Africa, lots of the mining projects are running, and due to this the pollutants from the mining activities, agriculture, and urbanization pose a threat to the groundwater quality, impacting human health and ecosystem. And the third challenge is the climate change, changing precipitation patterns and increase the drought challenge and the sustainability and the ability of the ground resources. And we will see the how the climates are changing through day by day. Now this is the study area. Basically, this is in the West Africa, and this is a 2D digital elevation map, and the maximum elevation here, and the maximum is 800, near about the 800 meters, and the minimum elevation this green parts. Now next thing is the 3D elevation. You can see that by the 3D elevation, this and this region is just like a valley features, and here the minimum elevation, and here the maximum elevation. Now come to the geology of this study area. Guinea country is a West Africa with a total surface area of the 278,519 square kilometer, and its features are driven geological landscapes by various geological process over time. This place is characterized by the influence of the Precambrian crystalline and Paleozoic rocks, The most Leo sealed, a crucial component of the Guinea basement geology, and in addition to the crystalline rocks, Guinea geological story includes a sedimentary basin like say bone basin. The Mesozoic and these are the A's, and Mesozoic Cenozoic sedimentary infill within the bone basin holds a significant potential for the hydrocarbon potential, and that's why the lots of the mining activities are going in this region. And what effect of the climates and what if how these affect to the groundwater, we will see. This is the overall workflow diagram for this. Is the first to collect the data from the NASA website and different websites like DM website. We will collect from the open topography websites, and basically we are focused on the five type of the meteorological variable, that is the relative humidity, shallow groundwater storage, and rainfall, and temperature, and we will see one by one the effect of this. After then the data analysis on the Guinea region, we will analyze the remote sensing data, we will analyze through the GIS and statistics for these variables, and then we will the mod flow modeling on groundwater levels, and finally results and discussion. And this is the box plots. You know, the box plots reflect the descriptive five types of the descriptive statistics, and this is the box and whisker plots. This is the whisker plots in which this maximum value is shown, has been shown, and this is the minimum value, and this is the median part, and this is the interquartile range, and this is the monthly data for the year 2022, and this is the variable for the humidity, relative humidity. Just see that in the month of the January, in the month of the this 7th month of the this it's about July months, and it's a maximum humidity is occurred because after the rainy season humidity is maximum. And from the you see the temperature at 2 meter heights, so the maximum temperature in the month of this April months. And from this you see the for the rainfall is the maximum in the month of this June months. And groundwater storage, shallow groundwater storage. What is the shallow groundwater storage? We will see next slide, and see the almost the same, but the maximum in the month of the January and February and December, because these are the post monsoon effect. Because in the there are three types of the monsoon. The first is the pre monsoon, second is the monsoon, and the third one is the post monsoon. In monsoon, the in monsoon is comes from the May to October, and the heavy rainfall has been occurred, you will see. And after then the post monsoon, and the recharge infiltration process is going on, and after the groundwater storage is going to up. That's why it is showing the high value. uh, this is the this is the monthly spatial analysis for the year 2022 for the meteorological variables, groundwater storage, rainfall, temperature, and relative humidity. The primary focus of this study is the shallow groundwater storage, that is the GWS for this, and GWS is the catchment land surface as a part of the global land data assimilation system. And especially GWS denote the water held below the soil and layers and the soil root zone and above the bedrock, and it is calculated by the formula used to the isolate GWS from the other water storage variable in the catchment land surface area is followed by the shallow groundwater storage, and it can be calculated by the subtracting the root zone soil moisture, snow water equivalent, and canopy interpretation from the total water storage, that is the TWS. And this is the calculator. And from if we consider on this map, just see this is the minimum value from this near about near about I cannot see this, near about 600 mm.
Yeah, it's visible. Go ahead.
Okay, ma'am. is a 600 minimum. Here is the minimum value is occurred, and here is the maximum value for the entire for overall the entire month of the 2022. Similarly, consider on the this rainfall. Rainfall is at the maximum value, and the maximum rainfall is occurred here, but the groundwater storage is the minimum here. This value is represent that the infiltration process in this area is not good due to the hard rock terrain area. But in this area, rainfall is minimum, but the groundwater storage is the maximum. So this area is in this area the infiltration process is going in a best possible way. Similarly, for the temperature and relative humidity, where the relative humidity is high, the rainfall is obviously is high, so it reflects and this is the spatial distribution of the these four variable. Now we will see the monthly spatio-temporal trend modeling for the year 2020 for meteorological variables, groundwater storage, rainfall, temperature, relative humidity, and yearly spatio-temporal trend modeling we will see for the normalized vegetation index for the March month, because March month is in the month of the March the vegetation index is high, and when this index is more than the 0.6, then this will indicate the good vegetation for this area. And the methodology for the selected these trend modeling, in this research the employed was a pixel based Mann-Kandal trend analysis on the raster surface of the remote sensing data, that is the groundwater storage, normalized vegetation index, relative humidity, temperature, and rainfall. Yes.
Can you conclude the session? Yeah.
Ma'am, yes, I'm concluding. The statistical significance of the trend was analyzed using the Mann-Kandal test, and the magnitude of the trend was estimated using the sense slope estimator. And the advantage of this test is it is not affected by the missing data, while and another advantage benefit of this is data data need not conform to the any specific distribution. From this it is clearly seen that if we consider on the GWS, this red color is showing the minus 23.5 to 18.83 mm per month. It is showing the decrease by the 23 to the 18 mm per month in this area, and here it is showing the increasing area. Similarly, for the rain, if we consider on the rainfall, here the rainfall is increasing with the rate of the 33 to the 41 mm per month. So rainfall is increasing, but the groundwater storage is decreasing. That's why it is indicating that the infiltration process is not in a good way. So we have to consider. I'm going to concluding the second part of this research is the workflow diagram for the mud flow modeling. Mud flow modeling is divided into two parts. The first is the conceptual modeling, and second is the numerical modeling. And conceptual modeling is establish a 3D model, and numerical modeling is establish a grid formation. And on this we will simulate this. And we will conclude the results from this mud flow modeling. We have simulated the hydraulic heads.
We are running out of time. Please conclude.
Yes, ma'am. I am concluding this hydraulic head, and from this hydraulic head we consider that its hydraulic head is vary from the 7 meter to 90 meter. And this is the volumetric analysis for the this is a volumetric result and for the steady state of the groundwater storage. Now come to the conclusion part. It is clear from the 3D and 2D DM visualization the steady area is that the GWS observed minimum at the higher elevation of the steady area. And finally I am going to the concluded this based on the compressing modeling conducted, it is advisable to prioritize the sustainable development of the groundwater level with a particular focus on the western and northern region of the northern region. And this is the reason we have to consider need more attention in these areas for the monitoring of the groundwater, because in this area the groundwater is in a depletion condition. Now studies for the sustainable groundwater use, water saving technology, rainwater harvesting technology, aquifer recharge technology, and the technology and innovation of the groundwater monitoring, remote sensing, smart sensor network. We are working on this data analytics methods. We have to say, and efforts and regulation and monitoring.
Yes. Okay.
Research and innovation. Thank you.
Within short period, we cannot make it. It's a wonderful work for management and all. So, is there any questions from the participant side, please?
Uh, okay, ma'am. Please.
Yeah, okay. Next presentation, Miss Amrita.
Okay, ma'am.
Miss
I'm going to
Amrita?
stop my presenting.
Yeah, you can stop sharing. Thank you, Sima. Amrita?